Okay, Algebra 1 fans, our topic for today, this is notes, and this is going to cover 3 sections in the book. It's solving systems of equations using substitution and elimination. We're going to use algebra techniques now to solve this. Last lesson we were graphing, now we can do it algebraically, which a lot of times can be faster. So our objectives, after this lesson, you should be able to determine if an ordered pair is a solution to a system of equations, and then solve a system using the substitution and elimination method. Before we begin, let me give you your joke of the day. Why couldn't the bicycle stand up for itself? It was too tired. 2 tires? Okay. So a little bit of a review here, some vocabulary. Solutions to equations. When you have a system of equations, that means 2 or more equations with multiple variables. So a system is just a group of equations that has 2 or more equations with more than one variable. A solution, what it means to be an answer to a system, those are the values for the variables that make all the equations true. The values for the variables that make all the equations true. It has to make them all work. Okay, so for example, is 3 comma negative 1 a solution? Here's the system. Here's 2 equations, x, y. One thing I like to do is I'm going to number my 2 equations. I'll use Roman numerals. There's 1 and 2. So to check this, I just take x and y and I substitute. So for equation 1, I do 3 plus negative 1. Is that equal to 2? Yes. Check. And then for this one, for equation 2, I do 4 times x, 3, minus negative 1, 12, plus 1. Is that equal to 11? No, it's not. So is this a solution? No, it's not, because it has to make both equations work, and it does not do that. So that's a no. Let's try this, 4 comma 1. So negative 3 times 4. This is equation 1. And then plus 1. That's negative 12 plus 1, which is negative 11. That's correct. Check. 2 times 4 plus 2 times 1. That's 8 plus 2, which is 10. Check. So is this a solution? Yes, it is. So here's the strategy when we want to solve these. There are 2 methods that I'm going to show you, and the first one is called substitution. And the idea of substitution is that we solve an equation for one variable, so we get it as y equals, or x equals, or whatever the variable is. It could be a, b, c, it could be anything. And then we take whatever that is and we substitute into the other equation, and then we solve for the variable, and then we solve for the other variable, and then we check. Okay, now that may not make a lot of sense yet, but let's do a couple examples. So number 3, let's solve. We have 2 equations, 1 and 2. Notice that equation 1 is already y equals something. In this case, the number is 3, so we already know the answer for y. So all we're missing really is the x. We're going to take this answer and we're going to substitute that into the second equation, which is x plus y is equal to 10. But in this case, we already know that y is 3. Now here's something that we have to understand. In a system of equations, the values for the variables are the same in both equations. So if I go back to number 2 here, this x value must be the same as this one. This y number must be the same as this. To be a system, it means that these have to be the same. Okay? So I know that if y equals 3 in the first equation, it has to equal 3 in the second. So now we have one variable and one equation. We can actually solve that. We have x plus 3 equals 10, subtract 3, x is equal to 7, and now we know x, and now we know y. So I'm going to write this as an ordered pair, 7, 3. It's okay if you write it, if you leave it like this. If you say x equals 7 and y equals 3, if you want to write it like that, is also fine. Now to check, well, the first equation I already have. The second equation would be x plus y, 7 plus 3. Is that equal to 10? Yeah. So both equations are true. Number 4. Okay, so again, equation 1, equation 2. Notice that equation 1 is already solved for x. We have x is equal to -6. So since we already know that, let's go ahead and substitute into the second equation. So 2 times x plus 3y equals 9. And instead of writing x, we replace it, we substitute with -6. And now we'll work it out. That's -12, multiply, plus 3y is 9. We'll add 12, and we get 3y is equal to 21. And then we divide by 3. Y is equal to 7. And at this point, we have both variables. The answer is -6 comma 7. But I do want to check. So in the bottom equation, I would do 2 times x plus 3 times y. That's -12 plus 21, and that equals 9, which is the value on the right side. So everything works. Check. All right, number 5 is a little bit different. Equation 1, equation 2. And the difference is that, okay, equation 1 is solved for x. It's x equals, but it's not a number, it's an expression. X is equal to 3y. Now you might think, oh, that's going to make it harder. Well, not really. If it's x equals, I'm going to take equation 2, and I'm going to do 3 times x minus 5y equals 8. But what's the value for x? What is that equal to? It's equal to 3y, so I will substitute 3y in that position. Now the reason why I want to do that, we can't find the actual values for x and y if we have them both in the same equation. But if we can rewrite the equation with the same variable, both of these are just y, we can solve that, because that's 9y minus 5y equals 8. We can combine like terms, that's 4y, and now divide by 4, and we get y is equal to 2. Now we're not done because we found y, but we need x. Now you have a choice. Since these x's are the same, you can take the y value and you can substitute into either equation, but sometimes one equation is easier than another. And in this case, equation 1 is already set up to find x. So I'm going to take equation 1, and I'm going to say x equals 3 times, but instead of y, I'm going to substitute the value, which we already know is 2. 3 times 2 is 6. And so our solution is 6, 2. Does it work? Well, 3 times 2 gives us x, which is 6. Check. 3 times 6 is 18, minus 5 times 2 is 10. 18 minus 10, is that equal to 8? Yes. Check. Both equations work. So you can always check these. You should always know that you're right or wrong. Okay, number 6, here's equation 1, here's equation 2. Y equals 2/3 x plus 4. And -3x plus 10x is 7. Now one thing that's kind of nice here, notice that equation 2 only has one variable, it only has x's. This is the one I want to start with. We don't always start with equation 1. I know we did in these examples, but that's not always the way to go. Let's take equation 2. These are like terms, that's 7x equals 7. Divide by 7, x is 1. Okay, now that we know what x is, to find the y, now we'll go to equation 1, which is y equals 2/3 times x plus 4. The x is 1, so I'll substitute that. So we get 2/3 plus 4, and if we add that up, we get 14/3. All right, in this case, you can write it as a decimal. It would be 4.6 repeating. But in this case, I would just leave it as a fraction. What I would say is that if you're going to write the decimal, you need to write the whole decimal. You cannot, don't round it to 4.7. 4.7 is not correct. It's 4.66666. And so that's why I would leave it as 14/3. So the ordered pair is 1, 14/3. Does it work? Well, if I put a 1 in for x, I do 2/3 plus 4, which gives me the y value. And then this would be -3 times 1 plus 10 times 1. -3 plus 10 is 7. Yes. Okay, so you'll notice I'm not showing my check every time, but I am plugging these in to make sure they work. And that is the end of part 1.